We saved a very intriguing topic for the end of our business track. Our next presenter, Andreea Mihailescu, is a passionate machine learning and robotics engineer, as well as a skilled software developer focusing on solving intriguing problems with cutting-edge technology. This presentation will showcase her inceptive work as part of a technical team of a conservation project, focusing on endangered population of giraffes and leopards in the context of surface roads infrastructure modernization and urban expansion. I'm so curious to hear about it, Andreea, so thank you for sharing this. Welcome.
Thank you, Christina, for the introduction. So I will not keep anybody waiting and share my screen. Just 1 second. Okay.
Now we can see you're sharing the screen.
So you can see my screen. Great. So my talk today will combine two of the most discussed topics today, namely in the Internet of Things and artificial intelligence. We will see together why for certain applications it is compelling to be moving from the cloud to the edge, and how everything should work away from a comfort zone and in harsh and secluded environments. So we have today an exponentially increasing number of connected devices. According to Gartner, it is a number of 29.5 billion of devices today in 2020, and they are expecting it to rise up to 43 billion by 2023. And there is a common expectation that the majority of these things will become artificially intelligent. Basically, intelligence enable edge computing and AI on the edge are facing the same surging demand in terms of capabilities on the device side as IoT was in terms of connectivity only several years ago. So we see the edge AI having just hit the peak of inflated expectations here in this Gartner chart. This was chart generated in 2019, so just last year. So what's next? So it is an universal truth statement that IoT generates big data, and this big data is issued mainly from 4 areas: wearables, smart homes, smart city, and smart industry. Basically, the next generation IoT solutions rely on a new suite of features that will ensure the commercial success of the new intelligent things. So we have shrinking in size dedicated hardware, and this hardware is becoming more powerful, upgraded with new standards such as COM-HPC, and hence expanding capabilities for heavier machine learning workloads on the edge. We have an increasing number of more specialized and smaller sensors that are embedded into on all our devices today, These sensors, we can see, for example, here we have a type of application which is a smart building, which includes lots of sensors, gas sensors, glass breaking, smoke and heat. Okay, here we have another type of application, a storage house, and These sensors here can be extended to supply chain. These solutions are adopting a hybrid approach, namely they also have algorithms on the edge side and AI algorithms which run in the cloud. There are still many solutions that adopt this hybrid approach. And here we have a connected smart factories as an example. But connected is something different than intelligent, as I said. So all these examples are fostering basically a new trend, meaning moving to the edge means of locally made decisions in real time in response to the information acquired straight from the surrounding environment. And what's next for the future means precluding any interactions with the cloud. Okay, so some of the market opportunities for mobile network operators. So we have, according to PricewaterhouseCoopers, these estimations, which are by 2025. There is an addressable market of $33 billion for platforms. This is $48 billion for cloud and hardwares, and it's growing up to $70 billion for applications, analytics and big data software, $110 billion, and professional services of $118 billion. If you want to target the IoT big data sectors, these are the top-ranked industries to target. So we have the highest percentage for manufacturing and in various industries, which is 30%, and 20% is transport and logistics. So the global IoT market is expected to grow at a compound annual growth rate of around 10.2% during the interval between 2020 and 2028. This market size is expected to grow from $916 billion in 2020 to almost $2,000 billion in 2028. The cumulative market is expected to reach 13,000 billion US dollars. But what is like to do business in the age of the AIoT? So we will see some examples here of businesses. So I start with Cemento Molins. This is a company which produces cement. It's mainly based in Barcelona, Spain, but has operations and cement factories all over the world. In 2017, it made a record, not only because it sold 6 million tons of cement, generating an earning before interest, tax, depreciation and amortization of 218 millions, but it's revolutionized its highly traditional operation through the application of artificial intelligence algorithms. So custom-made AI algorithms were deployed within the Cemento Molins factory in Barcelona, and this resulted in the increase of the production rate by 3.8%, the reduction of the energy consumption by 5.5%, and the improvement of its overall output quality by 3.1% in the first 6 months. What is important is that the algorithms provided a self-adapting functionality. So the cement industry is highly correlated to the local economic environment. So the demand for different types of cement also fluctuates seasonally. A self-adapting functionality is highly beneficial for the company since it customizes its manufacturing process and the type of cement it produces in response to demand fluctuations. Another example comes from Hugo Boss Turkey. Last year, Hugo Boss factory in Izmir, which commonly produces about 4 million pieces of products annually, saw an improvement in its operations due to the in-house developed AI technology. It resulted in a general saving of 2% fabric per piece and made a positive effect on its profitability. It's called the AA1 project, and it aims to reduce the use of fabric, which is the most costly part of men's clothing production, by using AI algorithms. For this purpose, the fabric optimization data that has been collected for the last 20 years in Hugo Boss Izmir has been entered into the algorithms and into its local platform to optimize the process. It has an additional tool module. It's called Oxygen, that facilitates decision-making processes by determining the needs of the employees on the grounds of the factory, and makes reliable and fast decision using the real-time collected data from the factory grounds. So the COVID-19 pandemic has been appreciated by many companies as beneficial to their tech innovation side. We have an example coming from Ford. Ford employees are experiencing with some smartwatches that vibrate when workers come within 6 feet of each other. So PricewaterhouseCoopers has developed an app that turns employees' phones into contact tracing devices, notifying them when they have been exposed to a coworker with a novel virus. Another example is an intelligent wearable coming from the senior focused digital health company called Care Predict, which this company rolled out a new set of contact tracing tools designed for senior living facilities in the United States. Pinpoint is a new set of tools broken up into 4 types of tracing: contact tracing, location tracing, path tracing, room traffic. The company uses indoor location tech to identify where a staff member or a patient was in the facility and who they came into contact with. And this is particularly important since the seniors in long-term care facilities have been some of the hardest hit communities by the COVID-19 pandemic. In the USA, more than 44% of the deaths are attributed to the residents in the long-term care facilities. So 75% of the enterprise data will be created and processed outside the data centers by 2025. This means that a lot of this processing will migrate to the edge. This is particularly challenging for the software developers, as they are constrained to drastically rethink algorithms, not only in terms of performance and resource availability, but also in terms of footprint and power usage. So we do have connected cars. I don't know if this still holds true, but it was expected that 75 of the global vehicle shipments in 2020 were supposed to be connected cars. But certainly for the future, we have the self-driving vehicles, and localized data processing and AI running on the edge becomes compelling, since this is an application that is very latency restricted. So as these devices IoT data, it becomes cost prohibitive to have a permanent network traffic. Contextual awareness and recommended features will gradually complete the intelligent behavior of all connected things around us, providing us with augmented sensing experiences. But what should we expect from intelligent and contextually aware sensor networks, especially in hard and secluded environments? So what is a harsh and secluded environment? So we have here some examples. We have some offshore operations in the middle of the sea or the oceans. We have cities hit by tsunamis and tropical storms, earthquakes, terrorist attacks, wildlife fires, or for example, places where there is no internet connection, like the jungles or deserts or savannas. So here we have some examples of companies which are active in these areas. We have the Indonesian Petrosi and the Petrobras in Brazil. And Petrosi actually developed an in-house solution for its mining business and offshore exploration, but Petrobras teamed up with Microsoft. There's ConocoPhillips and Engie, which teamed with Solution Seeker for their shafts explorations and undersea explorations. As early adopters of AI technologies, these companies seek to optimize their offshore exploration processes by contextual adaptation. They also take production to analytics to the next level. Both of the above examples use also the clouds to optimize production, to run production analytics and optimize their processes. They aim to mitigate equipment malfunction to preventive maintenance and improve personal safety by collecting real-time data from the scenes of the operations. So the Nordics group developed something with a product which is basically a platform called the Nordics OSTM SCADA Edge. It is based on an industrial IoT platform jointly developed with the Software AG and its Cumulo City IoT solution. To keep the cost of energy as low as possible, wind farms have to be operated at the best possible performance and availability levels. Each individual turbine is constantly adjusted by this SCADA system for the interaction with other turbines in the wind farm, and the ongoing wind data is processed in real time as well as the local grid conditions. So the Nordics OSTM SCADA Edge offers the possibility of accessing other components of the wind farm, such as a substation or battery storage. Some examples of solutions running in harsh environments. This is a StormSense project. It's an awarded project for smart cities, and it uses a lot of low-cost and low-energy water level sensors installed all over the east coast of the United States. This enhances the capability of communities to prepare and respond for disastrous impacts of sea level rise and coastal flooding in ways that are replicable, scalable, measurable, and make a comparable difference. This is a Prometheus project which uses ConvNet Quake, which is basically a combination of convolutional neural networks that detect earthquakes. So they do not predict them, but they detect them. So I'm going now to pass to one of the projects I joined during lockdown. So this is a map of Africa, and this is right here is Kenya. So yes, this is a conservation project going on in Kenya. And it's aimed at monitoring and saving giraffe and leopards populations. So Kenya is a country, I've never been to Kenya, but what I've recently learned is that it's a country where there is lots of infrastructure works going on, especially in terms of roads. So there are about 6 roads projects going on in the country right now. It's either a modernization of an existing road to enlarge it or the construction of a completely new road. So you can see here some examples of these roads. There are hundreds of kilometers and they are basically passing throughout all the countries, while they will bring some economic benefit in terms of for example, connecting commercial points from Tanzania to the northern Ethiopia, they will not be that beneficial for the wildlife. So what I mean here is that for these animals, these roads are not a blessing, but on the contrary. Why? Because Kenya has a climate which in most of the country implies that from April to March to June that there is a rainy season, and from October to December it's a dry season, and this is where the great African migration is happening. Namely, all the big herbivores are moving from Tanzania to the north of Kenya and back in search for what to eat, basically grass. So meaning this also affects the large carnivores. So why giraffes? Because the entire giraffe population in the world has seen a decline of 30% since the 1980s. And there are only a bit over 100,000 individuals left in Africa. And for example, these are the types of giraffes that we can find in Africa. And in Kenya in particular, there are only 3 types. This is the Maasai giraffe and the reticulated, and the type of northern giraffe called the Nubian giraffe. So how do we trace these individuals? Well, we trace them by a coat pattern. So as you can see, their fur looks different, and even among the individuals of the same species, the fur looks also particular for every individual. So giraffes, like elephants, are also following tracks. So they remember these tracks and they follow them. And the construction of new roads is going to affect their habitat very badly, because maybe they're going to pass exactly through one of their roads in search for food. So these animals do not know how to deviate. And this will result in even more population decrease. So leopards, the entire leopard population has seen the same, more than 30% decline since 1990s, with a 40 to 67 loss in habitat. There are around 700 individuals left in Africa. The most paradoxical thing is that although these animals are very popular, we know very few things about them, because they are popular because they have been hunted and poached down. They're not popular because they have been studied. So GPS tracking collars have been here for a while, but the GPS tracking collar only offer the position of the animal and its movements, and they do not tell us anything about a particular individual. So there is a solution coming from Africa Wildlife Tracking, meaning this is the collar. It connects to the satellite or to an ultra-high frequency tower with a GSM satellite uplink, and then it can connect to an AVT cloud, and the data can be accessed through web, mobile, or PC. However, in Kenya, due to the infrastructure conditions, this part here, it goes away. It cannot be accessed. And either way, I don't know how internet connection is in Kenya, but in Cairo, my best connection was 4 Mbps. So with 4 Mbps, I doubt that there is much that can be done in terms of connectivity. So the idea was to make these nodes, these machines that can be placed in trees or can be placed in bushes, and inside to store cameras and sensors to acquire information from the environment. The information stored on cards can be accessed from the mobile phone, and these nodes can be paired with the animal if it's within a range of 10-20 meters from this device. So this device is supposed to activate only when it senses either movement near the tree or either a signal coming from an animal's color. So this node has to be waterproof, has to be high temperature tolerance, has to have a battery autonomy of about 1 year. It has to be very resilient, because if a rhino decides to have a talk with it, most likely it's better to put a new device rather than to spend some money on something, building something fancy that is going to be destroyed maybe in 1 month. So it has to have low-cost hardware. And the connection is will be made through either 6-low WPAN, Ruby, or Zigbee to pair with another device. So what is inside? So we thought about 2 different strategies, either to have a Google Coral with camera and which runs TensorFlow Lite and which also runs the library AutoML Vision Edge, either to have a Raspberry Pi with a neural computing stick from Intel and running algorithms developed in the OpenVINO toolkit. So the ML models that are supposed to run on these nodes fit into the following categories. First, we have a detection to establish whether that particular movement means it's coming from an animal or from a person. Then if it's an animal, classification, what kind of animal is it? Is it an animal we're interested in, like giraffe or a leopard, or is it something else? And then it's pattern recognition to see if we're talking about the same individual. So far, the recognitions have been made solely through pictures, and this is how it's going to be also in the future. But we also envisage to try and include some other ways of detection. The devices must have night vision because, for example, leopards are mostly nocturnal animals, so they come out at night, and they have to be detected at night. The good news is that unlike giraffes, which move in families, the leopards are basically solitary animals, and if we can build something like an algorithm that senses also the animal's behavior, and we can make some meaningful insight out of it, it's going to be a more easy and useful detection. So I'm going to close this presentation, and I'm ready to take your questions.
Thank you. A great presentation. Thank you, Andreea. And now
I stopped sharing my screen. Yes.
Perfect that you stop sharing the screen. I have a few questions, but first of all, I want to tell you that I envy you effectively, because during the lockdown, you have giraffes and leopards, and I just simply ate more. That's all I did. Okay, so I have a question for you.
Yes.
How transparent are the algorithms behind the AI projects? How transparent are the algorithms behind the AI projects?
How transparent are the algorithms behind the AI projects? Which project in particular, mine or in general?
Your project.
Well, they are built using free tools, and transparent to some degree. They will be transparent and also universally available, but there is a problem because so far there is a web platform from where you can download photos already taken of giraffe individuals and leopards, but it's hardly accessible. I mean, I'm having real problems to connect to it to download photos. So to the extent to which we can actually upload this on that platform, I doubt that anybody will be able to download them without any problems. But I guess that if it's not an issue of confidentiality, they will be available on a GitHub repo.
Perfect. I would love to talk about your projects more, but in this moment we arrived at the end of the day, and I want to thank you and thank you all for attending. We hoped you enjoyed the presentations and found the learnings useful. I wrote some things down during the day, and I'm eager to discuss some ideas with my colleagues. I'm sorry it doesn't allow us to properly celebrate with a closing cocktail, but please do take another tour and stay for a chat. We look forward to seeing you all again at the next edition of Big Data Week Bucharest Conference. Thank you again and have a great evening.